All right, guys, let's look at infinite limits. So evaluating the limit of a function at a point or evaluating the limit of a function from the right and left of a point helps us characterize the behavior of a function around a given value. We've seen this. We can also describe the behavior of functions that do not have finite limits. So we can look at the example here. Let me see. What did I want to do? With the one that we looked at where we had the asymptote, so that's polynomial rational function there. We had an asymptote where it shot off at x equals 3, or excuse me, -3. That was the one. So what happens is with that one, we were shooting off in two different directions. So I could talk about what the limit was as I approached -3 from the left, which was going to be positive infinity. And then I believe it went down. I don't remember. But anyways, that's kind of the idea here. Now there's all kinds of definitions that go back over this. And so there's a big, huge box here that talks about some stuff. So infinite limits from the left. So let f of x be a function defined at all values in an open interval. So in other words, if you're coming from the left and it shoots up, and I'll let you read all this stuff, very technical stuff, but it basically means that if you're coming from the left and you shoot up, your limit's going to approach positive infinity. If you're coming from the left and it shoots downwards, that's going to be negative infinity. Same thing, we can define it in terms of the right. So we can say, oh, well, if the limit as x approaches a from the right, it shoots up, that's going to be a positive infinity. If we're approaching from the right and it shoots down, that's going to be approaching negative infinity. Woohoo! Again, lots of mathematical terms here that go into saying just that. And then a two-sided limit, if they're both increasing without bound, approaching the same number, we can say that a approaches, or a is positive infinity, and we write the limit as x approaches a of f of x is positive infinity. Same thing for x approaches a. If everything's approaching the same thing, we can say that it's approaching negative infinity. Cool. All right. So again, we've seen these kind of come up. We haven't got to talk about them too much. Here's some examples of that. So there are some rules that go with it. So they do say that if you've got f of x as something in this particular form where n is odd, it's going to look like this. If n is even, it's going to look like that. I believe we had this example of it. But just some stuff there. But please note, from the left here, we're approaching negative infinity, but from the right, we're approaching positive infinity. So the limit exists one-sided, right? From the left, it'll be negative infinity. From the right, it'll be positive infinity. But if I wanted the two-sided limit, that two-sided limit does not exist because you're approaching two different things. That's a little bit different than this one, right? From the left on this one, I'm approaching positive infinity. From the right on this one, I'm approaching positive infinity as I approach a. So on this one, the limit would exist. It would just be positive infinity. Is that all the stuff we just talked about? It is. Guys, we've already discussed what a vertical asymptote is. I've already went over that with you. Asymptotes make things section off. So cool, look at me. I'm already ahead of the game here. I think I'm going to do some examples now. So I want to look at these things kind of graphically. I think what we're going to do is they're going to give us some statements here, and we're going to talk about kind of what happens with them. These are thinking problems. Okay, so in the following exercises, consider the graph of the function y equals f of x. So that's y equals f of x. That is a lot of stuff going on, right? So which of the statements about y equals f of x are true and which ones are false? And explain why a statement is false. So our first statement is the limit as x approaches 10 of f of x equals 0. So the limit as x approaches 10. So approaches 10, notice they don't put it's not a one-sided limit, it's a two-sided limit. So we have to be approaching the same thing for the limit to exist. So on this one, here's 10. From the left side, it looks like I'm approaching 0, right? And from the right side, it looks like I'm approaching 0. That's the y values that we're trying to find. So yeah, I think that is a true statement because we are approaching the same thing from both sides. So true statement. Let's look at number 47. So the limit as x approaches -2. Now notice the plus sign behind the back here. From the right is 3. So let's find 3 here. Here's 3. And as I approach from the right, is it 3? No, excuse me, from -2, sorry. So I approach -2. Okay, so as I approach -2 from the right, they're saying that the limit should be 3. So as I approach -2 from the right, ooh, my limit is not going to be 3. My limit's going to be a positive infinity. Now, if that statement, to make that statement a true statement, if they had actually made this -2 from the left, that would have been 3. But from the right, no, we are heading towards positive infinity. Number 48. Oops, went too far. Limit as x approaches -8 of f of x equals f of -8. F of -8 is your function value. So in other words, when you plug in -8 or when you look at -8 on your graph, what's the y value that you get out of that? So they're saying is the y value you get that's associated with -8 the same thing as the limit as x approaches -8. So let's find the y value of -8. So the y value of -8 would be -3, right? There's no y value here because you've got a hole. So the y value of -8 is going to be -3. Now, what's the limit as x approaches -8? We actually looked at one of these examples in a previous video. So the limit as x approaches -8, remember, is on the function. So the limit as x approaches -8 is going to be -6. -6 is not the same thing as -3. It's not the same thing as a functional value. So that is also a false statement. Okay, number 49, the limit as x approaches 6 of f of x equals 5. Now notice there's no plus or minus behind the 6, so we're coming from both sides. We're saying that as we approach 6 from both sides, we're going to be 5. Let's see what happens here. So as I approach 6 from the left, I'm getting 2, right? I'm getting that y value of 2. But as I approach 6 from the right, I'm getting 5. So that is false. This limit does not exist because we're approaching two different things. Cool. What else can I do here? Those are the same type ideas, except you're actually finding the limits. So I think I'll leave those to you. I think we've beat that in the head. Maybe let's look at number 64. So number 64, the limit as x approaches 2 of f of x. So notice there's no right or left, it's just 2. So I have to approach the same thing from both sides. If we go to 2 here, notice with 2, I am not approaching the same thing from both sides. From the left side, I'm approaching -2. From the right side, I'm approaching +2, right? -2, +2 are not the same thing. So for this one, the limit as x approaches 2 does not exist. So there's another example of it does not exist. Anything else cool? I feel like we've just done the same thing. Yeah, this is all the same stuff over and over and over again. Oh, let's do this one. So we're going to do a quick word problem here, kind of put everything into context together because, word problems are what makes math like where you use it in the real world. So shock waves arise in many physical applications ranging from supernovas to detonation waves. A graph of the density of a shock wave with respect to distance x is shown here. We are mainly interested in the location of the front of the shock labeled XFS in the diagram. All right. So we are asked to evaluate the limit as x approaches the front of the shock wave from the right. And that's equal to, that little symbol there is our density symbol. So from the right, from the right, I was looking at it from the left. From the right, it looks like we were approaching not P2, it's our density 2, right? So we're at a lower density because the shock waves hit. So the shock wave hits like right here. So we're at P2 here, or not P2, density 2. I keep saying P, that's a Greek symbol. So we're at our density 2 here. So what happens when the limit approaches that shock wave from the left? So as we're approaching from the left, we've got our density 1 here. So, approaching two different things. So they want to know, evaluate the limit as x approaches x of SF of the density from the left and right. So from the left and right, just because we talked about, we're approaching two different things, right? We're approaching the density 1, density 2. So what does that mean in terms of the physicality of it? When the shock wave, before the shock wave hits, we're at a higher density, right? As soon as the shock wave hits, we're at a lower density. So that's why it doesn't exist. Something has happened. Something has created a change in your environment. You're at two different densities because of that shock wave. So yeah, there's just a real life example of where you might come across this, outside of a math class. Cool. Okay. That is this section wrapped up. So section 2.2 is done. We'll hit section 2.3 next.